If you caught my last video, you'll remember that we built the foundation for a login form, covering the basics of creating a beautiful interface, some key functionality, and even some nice transition animations. As highly requested from you guys in that video, today we'll be looking at how to build on this foundation to make the form fully operational, complete with a secure sign-up process, password recovery, validation emails, and even a Remember Me feature. Plus, I'll show you how to store your passwords properly so you're not an F-tier developer. You don't want to be that person. By the end of this video, you'll have a polished, professional login system ready to integrate into your own projects. So whether you're here to learn or to grab some code for your next project, stick around because there's a lot to cover. Let's get into it. Alright, there's a lot to unpack in this video, so to keep things moving, I've already written the code and we'll talk through it step by step. Now, if you haven't seen my video on setting up this login user form, pause here and check out that first. So you should have an interface like this, built with a surprisingly simple method. I've added on some extra pages to what I showed you there, adding a full sign-up process and tweaking a few other bits of functionality to make it more polished. If you understood the process, then making these other pages should be a snap. Before diving into the form's code though, we need to cover a few important points. For this video, I'll be using my database class to interact with a database that holds the user data, permissions, and more. If you're not familiar with how to set this up, don't worry, I have a full series that walks you through building it step by step. Yes, shameless plugs, I have no regrets. The only update I've made to the database class is adding a quick method for updating a single value. It's ridiculously simple, about 4 lines of code, but it gets the job done. That said, you don't have to use a database for this. If you want, you can store the user data directly in the workbook itself. However, I prefer separating the front end, in this case the user form, from the back end, the data, because it's just simply better practice. Keeping your data in a separate file helps you protect it from corruption and gives it a bit more flexibility in scaling the solution. Before we jump into the code, let's have a quick chat about storing passwords. You might think, I'll just store them as plain text. It's simple, right? But let me stop you right there, because this may be one of the worst ideas you could have as a developer. I'm going to take you quickly through the different tiers of password storage methods. Now, we're just going to do a quick crash course on this. This is the TLDR version. If you want a PhD on the subject, there's some excellent deep dives on YouTube. Here's a breakdown. F-tier plain text passwords. This is rock bottom. Storing passwords in plain text is like locking your house with a sticker that says keep out. If anyone gets access to your database, they've got everything. Plus, since people often reuse passwords, hackers now potentially have access to emails, bank accounts, or heaven forbid, their Netflix. Don't be F-tier, just don't. C-tier is encryption. Encryption sounds fancy. It turns passwords into gibberish using a secret key. When a user logs in, you decrypt the stored password with the key and check if it matches what they typed. But what's the problem? That same key can decrypt them back. If someone steals your database and finds the key, which they likely will, then it's game over. Better than F-tier, but still bad. B-tier, hashing. Hashing converts passwords into unique one-way gibberish that can't be reversed. So when someone logs in, their password is hashed again, and the new hash is compared to the one that's stored in your database. If they match, then the password is correct. Sounds solid, right? Except for rainbow tables. These are huge databases of common and previously exposed passwords along with their hashed equivalents. Older algorithms like MD5 are especially vulnerable, but newer ones like SHA-256 or bcrypt slow things down to make cracking harder, because if it takes days, weeks, months to populate a reasonable table of common passwords, they're just going to give up and go back to Nigerian Prince emails. A-tier, hashing and salting. This is where things get good. Salting means adding a random string to the password before it's hashed. So password 123 becomes something like B4A9SK3 password 123. This ensures that even if 2 people use the same password, the hashes are different. When the user sets their password, the salt is stored alongside the hash. At login, you retrieve the salt, combine it with the entered password, and hash the result. If the hash matches what's in your database, then they're in. Rainbow tables are now rendered useless because every password hash is unique, even for common passwords. Even if hackers know the salt, they'd have to hash each password combination from scratch. So what's better than that? Is there an S tier? Well, yeah. The ultimate solution is just don't do it. Don't store passwords at all. Use services like Google or Facebook login to handle authentication. These billion-dollar companies have security budgets that you can only dream of. But as of yet, I haven't put together a simple solution for implementing this with VBA. So let's stick with our A-tier approach, hashing and salting. So a quick recap: F tier, plain text passwords, just don't, please. C tier, encryption, slightly less embarrassing but still a big no. B tier, hashing, good, but rainbow tables can ruin it. A tier, add salt, hash, and compare, great. And S tier, offload the problem to Mr. Billionaire. Now let's move on to implementing A tier security in VBA and make your password storage. Before we dive into the form, let's take a quick look at the modules I've put together to help everything run smoothly. These might look intimidating at first glance, but I promise they're not as scary as they seem. First up, we have the database module, which is pretty straightforward. It contains a couple of constants for our database path and password, a public database object that our login form will use. And we've also got a connect and disconnect routines. The connect routine just makes sure that the database object is instantiated and then opens the connection. Database creation module, this one looks more intimidating than it really is. All it does is create some tables and toss in a bit of data, nothing too wild. Even though we don't need roles and permissions for this video, it's good practice just to set them up, and this is the basic structure for setting up a decently scalable application. Here's what it includes. We've got a user table. This is the most important one for today. This is where we store all of our user data and login information. And we've got roles and permissions tables for defining roles and permissions in our currently non-existent app. And then we have user roles and role permissions tables, which link the users to roles and roles to permissions. Next is the email tools module. Again, it might look overcomplicated, but it's just a method to send emails via SMTP. As long as the app has an internet connection, you can send emails if you've set it up correctly. I've also made a method so that you can really easily send off our verification emails, which I'll touch on a bit later. Down here are all the connection variables. You can use something like Gmail as I have. Just remember to set up an app password instead of your regular password. That way you're not storing your email password as plain text, which would definitely land you in F tier security. Then we have the encryption and decryption module. This is for the Remember Me feature. It handles obscuring the active user's details in the registry so they don't have to log in every time. This isn't the most secure solution, but it's simple and it gets the job done. A better method would be to use login tokens that expire, but that's a whole other rabbit hole that we're not diving into today. Take note here, don't reinvent the wheel if you don't have to. Even I've sourced this from online, specifically from a user named Motoraku on GitHub. I'll link it in the description if you're interested. Now the hash module for our password security. We're using SHA-256 hashing here. The salting process is handled in the form itself, so we'll cover that soon. But this module does the heavy lifting. You'll pass in a string and it spits out your glorious hash. Again, this code was available online. Use what's available to you. Work smarter, not harder. The link for this one will also be in the description below. Finally, we have the login module. I'll cover this in more detail at the end, but briefly, it shows our login form, gets the login state, and reacts accordingly. It also includes a simple logout method and a way to show a single worksheet, which is going to be our application for this example. Quickly, let me show you the mini method that I added to the database class module. As you can see, it's a simple routine that takes a few variables as arguments, formats them so that the upsert data routine can understand them, and pushes them on their way. It's just a small addition, but it makes updating individual values in the database a lot easier. These other class modules were covered in our previous video, so I won't get into those here. Now let's move on to our main event, the login form and how it all comes together. At the top of the code, I've listed the modules that it depends on. Why? Because future you will thank past you when you reuse this awesome login form for many future projects. If you forget to import the right components, things break and debugging turns into a nightmare. Listing the dependencies up front is an absolute lifesaver. If you watch my last video, you'll recognize the first three variables here, nothing new. Next, we've got a new collection called previous page, which tracks every single page you've been to. It's like a digital breadcrumb trail so that the back button always knows where to take you. Then there are a couple of variables for verification codes used between your routines, and one to track login attempts. We also have a public variable to hold a custom enumerated login state. This helps track whether the login was successful when called from the login module. After that, there's a bunch of constants. Some are pretty self-explanatory, and I'll explain the rest as we go. And finally, we have an enum to track a couple of state variables. I've organised the code into sections to try and keep things tidy. First up, we've got general events starting with the user form initialize. Here's what happens. We instantiate the previous page collection, and we call routines from the last video to create hover buttons, password fields, and set up page transitions. We reset login attempts to 0, and ensure the multi-page control starts on the right page. On the form, we've also added a checkbox which lets users disable animations if they're on a slow computer or if animations are acting up. We store this preference in the registry using the save setting and grab it using get setting. When the user form loads, we want to try and get the last value used, and if it fails, it will just return a default of false. Finally, we open a connection to the database and load the remembered user. When the user form closes, we just also want to make sure that we disconnect from the database. Before jumping into the buttons, let's look at the functions behind them. Instead of calling the transition to method from the last video directly, we've added a few steps with the change page to method. It takes the target page as a string and a clear page boolean, which determines whether to loop through each control on the new page and clear them. If animations are off, we add the current page to the previous page collection and switch directly to the new page. If animations are on, we use the transition to for our sleek slide animation and add the current page to the collection. I've tweaked this method slightly to return the current page value, which we then add to the previous page collection. We also have an update background routine. This swaps out the background based on the current page. In the form, I've added some simple controls off screen to hold different background images. It's pretty simple. Basically, a select case block checks the page and changes the user form's background picture. And this runs on our multi-page controls change event. The go back routine is the logic behind all the back buttons in the form. First, we use error handling to catch if there's an issue in the back process without ever interrupting the user. We use the highest index of the collection to get the most recent page and then we remove it. And then, depending on whether animations are enabled, we either transition directly or use the animated transition to method we covered earlier. The key here is that we don't add the backwards page to the previous page collection because we're already moving backwards. Now jumping back to the navigation buttons, these are simply calling a change page to method to move between the pages. The back buttons naturally call the go back routine. The verify move routine is a nice little extra. It's used on the verification code screen to smoothly transition between the two input boxes. This gives it a clean and sort of polished look. I'll dive into this more when we get to that part of the code. Next, we've got a batch of buttons, each with its own handler, which I'll cover at the end of the video. And then we have some visibility changes for a few error messages, things like username already exists or passwords don't match, displayed here to give users some immediate feedback. Then we have the animation checkbox, which the change event saves the user's animation preference to the registry immediately. This ensures that setting sticks between sessions without needing any extra clicks. Now, here's the quirk of using images as buttons. The enter key doesn't work by default. And let's face it, most people expect to log in by typing in their username, hitting tab, entering their password and pressing enter. To make this work, I've set up the processor handlers to accept a keycode parameter. The keydown event captures this code, and then each of these handler routines will take that, check if it's enter, and trigger its respective process. I'll show you the logic when we get there. It's a small thing, but it makes the form feel nice and more intuitive to the user. Next, these sections contain the core logic of our application, but before we dive into that, let's skip ahead to cover some supporting functions and routines first. They're the building blocks that sort of make everything work. Don't worry, we'll circle back to the main logic soon. So next we've got our initialized components. These were fully covered in the first video, so I won't spend time explaining these. The only difference is I've obviously added a few more buttons and password fields to cover the new parts of the form that I've built. Then we have our utility methods. First, we've got the verify move method, which I mentioned before. Here's how it works. When signing up, the users are taken to a screen where they enter a verification code. This function handles the smooth movement between input boxes. The code is simple. It checks if the user's input length is 1. If it is, the focus moves to the next text box and any existing text is selected. That's it. Next, we've got some check functions for the username and email fields. These run scalar queries on the database to check and see if the username or email is already taken. The display of error messages I mentioned before uses these. These checks are triggered when the user leaves their respective fields, sort of ensuring immediate feedback. Another important function is email validation during sign-up. I've used a regex pattern for this check, but if regex feels a bit daunting for you, you can replace it with something simpler like a string check. It's not as robust, but it does get the job done. Then we've got the password checks. These are really basic and just ensure that the password matches the confirmation password. In here, you could also consider adding some checks in to see if the password meets certain strength requirements. Here's a quick example of how I would implement a password check. First, we loop through each character using the mid function and then check its ASCII value with ASC. If it falls within specific ranges, we flag it as a particular type, like uppercase or number or lowercase. If it's outside of those ranges, then we can safely assume it's a special character. Let me just run a test routine here, and you can see that only the last password in this example passes because it has all 4 types of characters. It's simple, efficient, and gives us room to add stricter rules if we need to. And you can see with this routine what ASCII conversion of these characters actually looks like. So capitals are between 60 and 90 and so on. Next, let's jump back to our form code, and we've got to check to see if the sign up form is complete. This combines all the previous validation functions and ensures the name, email, and username fields aren't empty. If everything passes, the sign up process can move forward. I'll show you where this gets called in a little bit. Then we have the remember me handler. Here's how that one works. If the checkbox is checked, the app saves the preference, username, and password, which in here I've just labeled as token for added security, into the registry. Before saving, the username and password are encrypted using that encryption method I showed you earlier. If the user unchecks the box, those registry values are cleared and we save the preference. These values are tied to constants, which we declared at the top of the form for easy reference. And here we have some basic error handling just to ensure the process doesn't fail catastrophically if there's an issue accessing the registry. Instead, the user stays in the login flow without interruption. Now, this is where we actually load our remembered user. First, we check the user's preference in the registry. If remember me is set to false or not remember, then we can just exit the sub right away. If the preference allows it, then we pull the username and password from the registry and decrypt them. To ensure we don't get an error if there's nothing in the registry, we've added empty as the default parameter. Once the values are retrieved, we set the remember me checkbox to show the user's preference. Error handling here is similar to the previous routine. Basically, if something goes wrong, we clear the registry settings using the above routine. Now here's the fun part, saving the user data. This is where all those checks and preparations come together so that we can actually create our salts and hashes. This routine gets called once the form has passed all validations and it's time to officially save the user to the database. This line here grabs a random number between 2 constants declared at the top of the code. It converts the numbers into a hex code and slices out the first 6 characters. That's it, you've got your salt. These examples here are just what the salt looks like when they're generated. Next, we gather all the values from the sign up form into a dictionary. Then the password hash is created by combining the salt and the password from the text box into a single string, and then passing it through the SHA-256 hash function. Then we store the salt. Don't worry, storing the salt alongside the hash doesn't reduce security. Hashing is a one-way process, so even with the salt, the password can't be reversed. We also include the sign up date and last password change with the now value and set the active field to true. And finally, we pass all this data to the user table of the database. It's as simple as that. The forgot password routine works similarly but updates an existing record instead of inserting a new one. So here we pass the user ID to identify which record to update. Then we generate a new randomized salt. We use the salt and the new password to create the hash again and store that and our salt again. Then we update the last password change field with the current date and time. Then we just save these changes back to the database. Pretty easy, right? Here's a quick view of what these records actually look like in the database once they're saved. You can see that even if you get access to this, you're not going to be able to recover a password from this hash. You can try and figure out what my password is from this if you want, but I'll save you the trouble. My password is password. And that's it for all the helper and utility routines. Everything is now kind of set up and ready to go. All that's left is to jump back into the core logic routines and see how it all ties together. We've got a total of 5 routines here, and they all accept a keycode parameter. At the start of each routine, we check if the keycode was provided, and if it was and it's not enter, we exit the sub. This ensures that the routine only runs when the enter key is pressed or if no keycode is passed at all, which would happen if the user clicks instead of presses enter. It's simple and it works. So let's start with the forgot password handler, which is for this screen. This routine kicks off the password recovery process, including a verification system, which I think is pretty cool and is surprisingly simple. Here's how it works. So if the email isn't valid, we immediately exit the routine. We grab the user ID from the database based on the provided email address. If the email doesn't exist, we simply jump to the next page anyway, which says something like, if you've provided a valid email, you receive a verification code. Spoiler, they won't. Similar to how we created a salt, we generate a random 6-digit number, convert it to a string, and store it in a global variable. We change the page before sending the email. This avoids the app hanging while the email is sent, which could make the users impatient enough to start clicking around. Using the send verification code routine from the email tools module, we build an email with the verification code and send it off. Here's what that looks like in case you missed it earlier. Just builds a basic email, adds a verification code, and sends it off via SMTP. If all goes well, the user receives an email with their code and moves on to the next step, resetting their password, which corresponds to this screen. So here's the flow. First, we make sure the new password and confirmation passwords match. Then we compare the recovery code text field to the global verification code that we set in the last routine. If it matches, then we proceed. Just a note to self, I just realised it would be smart to add a limit to the number of attempts here. Otherwise, someone could essentially brute force all possible 6-digit combinations. I'll definitely add that in later. Then we call the submit forgot password routine we just covered down the bottom and use a scalar query to grab the user ID from the database based on the provided email. If everything checks out, we show the page confirming the recovery process is now complete. The sign-up process is similar. This is for this screen. First, we check if the sign-up form is complete and if the email is valid. If it's not, the user won't get a verification email, so there's no point in continuing. Just like in the forgot password routine, we generate a code and store it in the global verify code variable. Before switching pages, we just quickly clear all the verification text boxes and then we focus on the first one. The verification code is emailed to the user and that's our sign-up process done. The next routine handles the verification process itself, which is referring to this screen. We loop through each of the verification text boxes and compare to the entered values of the verification code. If any of the values don't match, we jump to the verify error label. If everything does match, then we call that submit sign-up routine from before to save the user to the database and move on to the success page. And after all of that, we've reached the most important routine of the entire process, handling the login event. This is the centerpiece of everything we've been building to so far. This should be pretty obvious, but we're referring to this screen for the login process. So here's how it works step by step. First, we query the database for the user ID associated with the username that the user has entered. Then we fetch the user's stored salt and password hash. Before we proceed, we ensure the user's Remember Me preferences are updated by calling the Remember Me handler. We then hash the password entered on the login screen along with the salt we retrieved from the database. Then we compare the result to the stored password hash. If they match, then it means that the user has entered the same password that they signed up with. If the hashes don't match, we give the user an error message and jump to the login failed label. Here we track the user's login attempts, and if they exceeded the maximum number of allowed attempts, we set the public login state to failed and close the login form. If the hashes do match, then we move on and check that if the user is marked as active in the database. If they're not marked as active, then we warn them and return to the login failed label. If everything checks out, then the user has obviously successfully logged in. We call the new database method to update the last sign-in value based on the user ID with the current date and time. And finally, we set the public login state to success and hide the login form. And that's the entire login process. Let's quickly look at how we would call this form and transition into an application. So here's what happens in the login module. First, we create a new instance of the login form and show it. Because the form is modal, the code won't proceed until the form is closed. Once the form is hidden from within the login form code, we check if the login state equals success. We then just unload the form to make sure it's not lingering sort of in the background. If the logged in state is true, we show the application sheet using this show only routine. This process works just as well if you have a user form based application. Instead of showing the application sheet, you'd just show your main application user form. And there you have it. You've got a fully functional, secure and intuitive login system. It's super easy to use now thanks to all the hard work we've put into building this comprehensive solution. Now, all the code you need is right here in the video. If you followed along with the process in the previous video, creating these additional pages that I've set up should be pretty easy. But if you're looking to save time and want to grab this exact form to start using right away, While also supporting me, head over to my Patreon. I have 3 membership tiers. The lower tier membership is perfect if you just want to show a bit of support and help me continue creating content like this. My mid-tier membership unlocks access to all the files I've used in my videos, plus some other exclusive content which I won't release on YouTube. And finally, my highest tier membership actually includes a monthly one-on-one tutoring session with me personally to really sharpen your skills and take your projects to the next level. If you've enjoyed this content, please take a moment to like, subscribe, and share with your fellow Excel enthusiasts. And don't forget to leave a comment below, let me know what you thought of the video or what you would like to see next. Thanks so much for watching. Until next time, this is your VB Tutor signing out.